Hello and welcome back to Compiler Programming. In this video, we are continuing on the improvement path for the encoding, and in particular on decoupling encoding from the way we deal with basic operations like moving values and arithmetic operations and so on. And as a next step, after the cleanup of instructions that happened in the last video, I'm gonna go and change the way we deal with the encoding in function builder. In particular, we will no longer directly call encode every time we do an operation, and instead we will buffer up all the instructions that we need to encode, and only then, when we are done with the function, we will in one go flush them all out and do them all at once. This will need some changes to the way this is done. So we start with function builder, and inside function builder, I will be lazy for now and will not do dynamically sized arrays, even though we'll need to do it at some point. And I say max instruction count is whatever, 496, and then I will do it like so. So we have instruction star instructions, u32 instruction count is like so, and actually I will put this over here so to say that they are connected. Good. Now when we create a function builder, we will need to reserve this memory the same way as we do for stack displacement, which we might be able to get rid of later, which is good. So I think function builder, where do we have function begin? Is it here? Function begin, yeah. Okay, so this is where we allocate stuff for this stack, and now we will do the same thing for our instructions. Max instruction count. And these things I think I will actually change to regular malloc, but we'll see. Because technically we could start managing memory a bit more carefully, and for the instructions and stack displacements, we know that when we are done with encoding, so when we do function end, that is the time when we can free this memory, because we don't need this anymore. Okay, so for the instruction, it's gonna be size of instruction times this. Okay, that sounds good to me. Let's check this out. Did I screw up something somewhere? Okay. Instruction, redefinition, different basic types. So I guess it's not happy with this thing, because instruction right now is defined in here, and we need to extract this into a header file. So I'll just do this. Instruction.h, yes I do. Okay. And we also now include instruction. In the value h, we can do this stuff. If in def instruction h, and get rid of all of this junk. Let's do it like so. That sounds good to me. We do need to include value h. I should not have removed this. And in here we can remove this include, and we can remove this type def. And then actually we now have a bit of a problem that this stuff needs to be inside. Yeah, we actually don't need this header. We will shove all of that into the value, because otherwise it will be just mutually recursive. We can like do forward declarations and all this jazz, but I don't want to get into this dances with C compiler just about now. So let's try it like this. Yeah, this value. Instruction is not a member of function builder. That seems much better than what we had before, and because it is called instructions. Cool. Let's try to run tests. Nothing should change because we're not actually doing anything with that memory. But since I switched it to malloc, let's also start with freeing this stuff. So we can do free of builder temp hedge list is, or no, it's stack displacements that we can free. Let's check. Okay, that seems to be just fine, because here's where we resolve it, I guess. Oh, this is different jump hedge list, whatever. This can be freed, and instructions can also be freed. Okay, sounds good. Now we should actually use this. So the first thing to do would be to we need to change all of these encodes into something that will push into the function builder array of instructions. So let's do that. I think the easiest way to not miss something would be to just rename this to be encode instruction, and if we now build, we'll have a bunch of errors that we can start dealing with one by one. So in code, first let me fix this, because we should have changed function to builder everywhere already, and it's a bit annoying when it isn't. Okay, so now we change encode. Yeah, we can call it encode, that's fine. And it will have sort of the same signature as this, or maybe let's call it push instruction to more precisely tell what it does. And here it's pretty straightforward. We just say that we assert that builder instruction count is strictly less than max instruction count, and then we do the standard thing of builder instructions. Builder instruction count is instruction, and we increase the count. I could do it in here, but it's a bit more explicit, so let's keep it this way. Okay. We now change encode stuff to be push instruction. Why don't you like this? Function declare identifier. Yeah, it's called builder now. Here it's also called builder. And then here as well. Okay. L value specifies const objects. Does it? I'm a bit confused about that. So it says that this is a const object. Instruction. Maybe it's unhappy about this const mnemonic. Okay, I guess so. Push instruction. We can look for encode and just replace it with push instruction. Nothing really fancy here. Okay, looks like we are done with this file. But there is still stuff in this one, so let's fix that as well. And we have built successfully. Of course, if you try to run it, which I'm not even going to do, nothing will happen, or it will crash horribly, because we are pushing these things to the array, but we are not actually doing anything to them, which is something that we need to do inside function encode. So in here, we have these push instructions, and this is actually quite interesting, because these two instructions should be done after we do this resolve jump patch list, which expects the code to be already inside of the inside of the buffer. So I think these three for now will have to stay as encode instruction, because otherwise they will do the wrong things. But to keep the previous behavior, I think in here we can just iterate over all the instructions and output them. Now that I'm thinking about it, it is also possible that our jumps are actually not gonna be correct, because if I look at make JZ, then I believe it will yeah, so this is a bit unfortunate, because right now our code looks at the occupied offset when we are doing this make JZ. So we will have to change all of this stuff to instead operate on something like a label, like in assembly, that is different from the actual instruction pointer that we have here. So that's gonna be another thing that needs to be taken care of. Do we have it here? Yeah. So patch 32 is now gonna be something else. It is going to be, I guess we do this v32 instruction index, and that will also generate a bunch of problems for us right now. Okay, so patch jump to IP. That's interesting. Where are you used? So this happens when we end the loop. So I guess that would mean that instead of this patch jump to IP, we will need to also push somewhere this index, and then when we are doing the main pass, resolve that. I will keep this for now and just write out the main thing to show you maybe a bit better what is gonna happen in the end, and then we can continue with this stuff. So the idea is that in here I do pretty standard stuff of saying A4, you know, U32 or S32I is 0, I is less than builder instruction count. We go through I, and then we say encode instruction of builder instruction I. Pretty straightforward. We also need to pass the builder, at least right now. Okay, that builds, but we have this problem with patches. And I guess what we will need to do is we will need to have another array. So we say something like U64 instruction or instruction index offsets is malloc size of U64 times builder instruction count. So here's what I'm trying to do. Previously, we would have something like move, I don't know, arrayx, rcx. And then when we say that we want to have an if, or I don't know, ampere arrayx rcx, then we want to do if, we would need to say, okay, I actually would want to so here gnz whatever xxx, and this xxx would be somewhere over here. So this would be the code that we need to write, and here we will do some other code. And the way it worked before is when we did this kind of stuff, we just said, okay, some instruction pointer is going to go in here, or the difference between two instruction pointers from here to here is what we will need to write there, and we will just do it in absolute values, and we will calculate it that way. Now what I'm saying is we will associate, like we have an index for each of these instructions, right? So 1, 2, 3, whatever this is, and then together with this label there will be some kind of instruction at, for example, 4. And when we write a jump inside this patch value that we have, we will just record that actually I want to jump to, let's say I want to jump to 4. And actually it's better explained if this is other way around, like this, for example. So like if it's beforehand, right? So I want to jump to just 1. And but 1 is at byte offset what? Well, to resolve from these indexes into actual byte offsets, we will use this extra array that will just, after each time we encode an instruction, we will record that. So because, for example, compare array xrcx, I don't know, it will take 5 bytes, whatever. So we will say that, okay, the first instruction will start at 5 bytes and then so on and so forth. We can even record this after the instruction because this is more or less what is required for the diff calculation. I don't know, something like this. Let's see how it will work. So let me bookmark this stuff and figure out how all of this will work. Okay, so what does it do? It does push instruction of JZ, and it this should actually be CC. Then we store the current position in the buffer, and we say that location, what is this? Location is where we need to patch this stuff. Okay, that's fine. Yeah, okay. So this is quite interesting how we're gonna change this stuff around. Maybe we can start with a simpler one. So this is actual patching. That's fine. The problem is that we will need to somehow change this code, like to also defer this patching as well. Like deferring this is not a problem. Deferring this is right now the issue. And I guess to make that happen, what I will have to do is introduce another structure which will hold the labels as, that we will use for tracking all of this jazz. So do we need the labels here, or can we do this when we end the function? Let me try to write how the code would look like. So where are you used? Let's start with this regular jump because it might be slightly easier to figure out. Okay, make loop end. We patch jump to IP, which is loop start. So what this should change to is we need to say, when we create a loop, we mark the start of the loop with the label, and then here we just say jump to that label, but we don't actually call this resolve jump patch list, I believe. What do you do, resolve jump patch list? While jump patch, patch jump to here. Why are we doing this in the first place in here in make loop end? This seems pretty strange to me, to be honest. So I'm not sure about why we are doing this. Sure why this is required. Maybe I should go back and watch my own videos. Anyhow, let's just figure this out. So instead of patch jump to IP, we have to say something like so loop builder will have to contain now a label. So instead of start IP here, it needs to know where to jump. So it either needs to have an index and then we store it in another array, or we need to make it jump patch list. Yeah, okay. Now I was blind. It has its own jump patch list, so that's fine for breaks and continues. Now remember. But as far as the top goes, label. Let's just say that it will look something like this. Where else do we use? So I guess in continue, right? Let me mark this as well, and I want to look for continue. What are you doing continue? Break is... So break adds something to the jump patch list, okay, and continue, it just goes to the top. Okay, I think what I will do is, for now, I will disable all of this stuff, all the ifs, all the patches that we have, then try to see how the code that does not use any of them behave, and then slowly reintroduce them back into the code. It might be easier to just re-implement this stuff from scratch rather than try to figure out how it fits into older setup. Okay, what's wrong here? Oh, I guess this one is not used, but that's fine. Or maybe that's not what the problem is. Assigned, unsigned mismatch. Guess it is U34. Okay, that's better. Resolve jump patch lists. Yes, let's kill this for now. Let's kill this for now. We need to remove all of these as well. And I forgot to remove this. What's happening? U64 difference from the level of, yeah. Okay, that's good. We have a bunch of stuff here. In particular, we need to remove this loop. We need to remove, so I guess our maybe cast2 tag is gonna be broken as well. So let's remove this function as well completely. This is fine. This is another test that goes away. So we do this. We remove this test. And here actually we should remove the whole tests instead of just the loop. Okay. There is a bunch of errors here as well. Fibonacci is sadly off for now. Okay, so with ifs out of the equation, this code should work. And this is something that we can actually debug. Okay, it works for a lot of the stuff. So all the tests that are not connected to the function actually pass, but function tests seem to be having a bit of an issue. So let's see what is going on. Sorry, definv mess solution. Let's try to debug that. No, we'll recover. I don't know. Let's see what the debugger says. I need to change this stuff here to say function spec. Good. Start. Okay. We are somewhere really screwed up. Where are we? At all? Okay, let me open function spec and just, I guess, step through the code. So it explodes in the first test. Let's see. Okay. Team. Okay, something gets encoded. But the question is, what did get encoded? So step here, go to disassembly, and go inside. So this more or less looks okay. Okay, so the function calls are screwed up. This is what is happening. And this is screwed up because yeah, I guess this return patch list, no, that is probably wrong. Okay, let me go back. Let me see the actual test before I jump to conclusions. Yeah, this one returns 4, this one returns 8. And it just calls both of them with different arguments and then stuff. Okay, so what does call actually do? Call function value and then yeah. Okay, well, call function value it is. So this is this stuff where we push the fake address which is what happens here, right? But oh, okay, yeah. So this is essentially the same issue, and maybe that's the first one we will tackle, or the only one we'll tackle in this video for the labels. We right now don't have like functions exist at a certain address, but we were expecting this to be already known, and everything just sort of falls apart if we don't do it. Okay, so let's, what do we need to do? We need to store this location to patch somewhere, and then we need to resolve, like when we are in, after we encoded all the instructions, we need to go in and put this stuff in, except we don't really know what this location is. So inside of instruction, we need to somehow say that this is a patchable operand. Let's put it this way. And then when our encoder sees a patchable operand, it will put it in some array somewhere that we can later refer to. I guess that would be a reasonable way to do it. But that also means that our operands need to be slightly different, and at least they need to have a flag or a set of flags maybe. So let's say D32 flags, and then we do type def enum operand flags, or operand flag, I don't know, operand flag hatch or label is one. Okay. So here now we say that operand target is this, target flags or equals operand flag label. Okay, this seems good to me. Now we put target here. We don't have all of this stuff anymore. I guess we could move it to the main code, but for now I will just do it like so. Now our encoder needs to be able to do something with this. So it already has this stuff somewhere that tracks, I believe, these things. Yeah, this is done for stack displacements, where we are tracking all of this, and I guess the labels would be just a more universal mechanism to deal with these things. So instead, what should I do? When we write out an immediate operand, I should say that, how should it go? I guess I will do if operand flags and operand flag label. Then we need to do something. In particular, we need to say something like push label Need to think about this. So yes, we can push the label here just fine. However, let me go back to this code. So the actual target is this stuff, and looking at this, we might have a bigger problem. So when the function is created, it also needs to have an associated label with this. And when we call that function, we just say, okay, actually, call this label. What it will do internally is it will create this placeholder for now, but then when we encode the function, we resolve the label, I guess. So in a sense, labels, it looks like labels will need to be a higher level abstraction than what we have for functions. So like they are not attached to function builder, they will be attached something to, we need to create a new thing that is going to be, I guess, instruction builder or something like this. So let's figure out how something like that might look like. So if we do have an instruction builder, and I guess maybe functions will need to refer to that instruction builder in some form, or maybe we can get away with just labels for now. Okay, let's not end this and just say that def struct label, and label literally just needs to have an offset, but we don't know what that offset is. We just know that it's something, and each function will have a label, but we always will pass it by pointer, so we can update it later on, I guess. Yeah, something like this. Okay, label. When we create a function, it is 0. That's perfectly fine. And then when we end a function, we will record this. Actually, when we start writing a function, right now at least, we do know what will be the start address of that function. So in a sense, it already even contain the right thing there. Let me think about this. Yeah. Do function, so this also needs a bookmark. We'll have a bunch of them. So this would be our main loop, right? But when we get to function begin, at this point, we can record what is the offset in a buffer, right? So this stuff, we can store this as the label of the address of the function. And when we do the call, we just say jump to that label. Sorry, it should be a bit here. Function begin, builder, okay. And we say label is label of this. Right, so we store where the function starts. And when we do the call, which is over here, we will need to have something like jump patch list that records all of this stuff. So if this is a label, no, we don't need the operand label, I guess. What we need to do is target, so builder, label patch list, unimaginatively called. And inside of that label patch list, we say that we would like to so just in pseudocode, we say push this offset for immediate is where we need to do it, right? Push label patch. Here we say to call. But to call is a value, and the value does not have a label. So actually, this label should not go to function builder. It should go to the function itself, because otherwise we don't know where it is. Or should it go to the operand of the function? What is the operand of the function right now? Let me look at this. So this would be in function, and I guess function end doesn't have an operand, but function begin, result. Okay, so operand is just this stuff. So we are builder.code. What is that? Builder.code, builder.code. Okay. So we have memory plus buffer occupied. So this is the same as what I was trying to write here. This is what we say will be the result of this stuff. I guess that's fine if we do it this way. Okay, so let's just go here and figure out here what we can do. When we encode an instruction, we need to figure out if we need to update any of the offsets to be something else. How do we do that? Maybe it would be best if we do it after the fact, because especially with ifs, some of the diffs might be forward and not just backward, so we can't really do it in here. So there will be some kind of loop here that is similar to this one. that will go through all of the, let's call it label patch list, and it will do something. So it will say that if we keep this as so and say patch 32 patch star is builder label patch list of I. Okay. And what we do is we say patch location is what? Patch location is, okay, this is interesting because for local jumps we can just use this stuff where we will record all the offset indexes, and I can show you what that would look like. So it's going to be in the instruction index of set. I is builder set builder memory plus builder occupied. Actually, we can just store builder occupied in here. That's okay. Or we can do a full thing. It doesn't really matter. And then we change it from U64 to void star. So we just say, okay, this points to something. And then we can change this to void star. Okay, so these kind of things will record where each of the instructions that of this particular function start, right? And this is what we can use for local ifs. However, for jumps between functions, unless we move out this whole encoding even one layer of this, where we introduce the concept of a program, which we probably should, then we cannot use a similar mechanism. But on the other hand, right now we only call functions that were declared before, so we do know their offsets. And if we say that we are only dealing with those offsets, then we can use this kind of stuff where we would now go in, and this patch will contain a slightly different thing. It will say where in our functions was this patch, and what do we need to, like, how are we gonna jump back from there. More precisely, we say patch location, so it's gonna be star patch location is we will need to look up in this array. So this patch should also say patch target let me think about this. So indexes here, they will be at the beginning of the instruction, but this is not necessarily, like, this is not the location where we need to patch. We, like, it's always offset because there is part of the instruction that is the actual code, and then the location. So this might not even be useful for us in the case of function calls at all. Instead, okay, getting back to here, we need to somehow say to the thing that does instruction that it also needs to remember this stuff. So let's restore our flags and say, but it's actually not just flags, it's more like we need to have a new type of operand. And that might be a better option, honestly, to deal with it. Although if we do introduce new operand type, then it's going to be a bit of a mess inside of the encoder as well. Maybe. Okay. Not feeling super concentrated today, so need some time to get my head together. We have value. Value has these operands, and when we have immediate 32, this can refer to a relative jump. When that refers to a relative jump, we need to know where this relative jump will be encoded. And instead of saying directly the address, we just say, actually, wait, it's going to be something that I will later tell you what it actually is. One way I could work around this stuff right now is if I say this is no longer, yeah, let's introduce a new type. I'm a bit not sure about this. Say relative 32. We have already rep relative here, so this is not exactly the same thing. So let's just say relative 32. And relative 32 will just go in here. It's sort of the same thing as immediate 32, but it has a different interpretation. Okay, so we have relative 32 here, and relative 32 actually will not get a 32 here. Instead, it will be like so. So we have a label. It will point to some particular label inside of our code. So maybe I will not even call it relative 32. I will call it label. And then we need to update stuff here. So let me remove this thing because it's no longer a thing, or shouldn't be a thing. I will remove the flags. And in here, first of all, I will add a thing that says that if it is this, or we can also say that, let's be more explicit here and call it label 32, because if we have different sizes, then it might not work out really well. So let's call it label 32. Okay, and then we have operand type label 32. Okay, this is what we have. It does not know what the label is. That's perfectly fine. I think it's defined somewhere below. Yeah. So label is, I don't think it actually even needs to have anything inside of it, to be honest. This is just a pointer that we will use for correlation. I mean, it can contain the list of things that refer to it, I guess. So maybe this is what we do. Maybe we just say S32 star locations and U32 location count, and we say define max label location count. Yeah, maybe something like this would actually work. So we create this thing that we say, okay, we have a label. And then whenever we use it in the operand, we just record, oh, we actually used it here. We encoded it at this particular position. And then when we go through the list again, we just patch those positions. That sounds honestly pretty good to me. Yeah. Good. When we do function begin now, function begin dot label is it gonna be inside the function or is it not gonna be inside the function? Yeah, I believe it will be inside the function. So we say label, and here is stuff where we say dot what was it called? Dot locations is malloc size of u or s32 star times max label location count. What's wrong here? I wonder. Okay, first let's do here. This is just a debug loop that it complains about, so relative unimplemented error. That's fine. Label 32. Undeclared identifier. I guess it's has an underscore in there. Okay, this file is fine. What is happening here? This needs an underscore. That's good. Good here. And a bunch of errors over here. Max label location count. Not sure what the problem is now. Syntax error, closing brace. I guess it complains that now there is no such thing. Okay, yeah. Label. Still not sure what's going on. Where am I doing weird thing? function builder has a label now. What is going on? What are you complaining about? Memory is not a member function builder. Yes, it is. I'm very, very confused at this particular moment about what is going on. Okay, now we're complaining that we don't know what the hell the value is and label is and everything is broken. Okay. Say, here's the label, everything is fine. Label page list. Okay, so let's remove this stuff and try to shorten the error list. Builder memory. It's not actually builder, it's buffer, I guess. Flags. Okay, so this also goes away. That's fine. Okay. We are getting somewhere. I still want to like this. Say locations is size of S32 star. Okay, that's good. Here is cannot convert from void star to void. Huh? Oh, I guess it is void star star. Okay. Now here we don't know what to do, but here now it's slightly different. So instead of EIMM32, we will have another thing that is going to be called a label 32, and it doesn't actually take any. No, it takes the label star label, it creates this label 32, byte size is 4, that's correct. And here it will be label 32 is label. Then I put it in here and see what is gonna happen. Okay, we cannot use this anymore, that's fine. Instead, instead, the label actually also needs to have void star target. And these targets, so this basically allow us to separately resolve the target and separately resolve these, and when we know both of them, we can go through and figure out all the offsets. So that means that here we also need to say yeah, as I mentioned before, we also need to move this stuff or not. So target. yeah, we just do to call operand. This is what it should be. And then these to call operand, here we'd have a different type. So even this stuff becomes actually better. We don't really need to have this start address, end address anymore. We don't care. We just say, oh, is this whatever we are trying to call, is this label 32? Cool. Then we can just directly call it. And if it is not, then, well, too bad. Okay, this is getting nicer. Let's see. Okay, this builds, but it definitely will not do anything even remotely nice for us, because we still have to go into here and say, do this. If operand type is operand type label 32, then this is okay. We append 0x. So we append the placeholder, and then in operand label operand label locations, location count is less than max label location count. This is an assert that we want to have, right? And then you say operand label location. Actually, we should do this after we do the immediate, because we want to point to after the function. Or does it matter in this case? I guess it doesn't. Let's think about that. For now, it probably doesn't matter. Operand label locations, operand label location count is buffer buffer memory plus buffer occupied. Okay. I think now we are actually, as far as patch goes, this is it should be before here. Yeah. Okay. Buffer memory plus buffer occupied, and we just cast this to S32 star. Okay. Label is not a member of operand. What? Okay, whatever. S32 differs in levels of interaction from S32 star. That's because this actually should be an array of pointers. Okay. We have whatever. This is why this was actually very unhappy. Yeah. Okay, good. Here, what do we do? We have this stuff. We need to not forget to increase the count. That sounds good. So when we output now this label 32, we will record where we did output it, allowing us to later patch this stuff. So nice. And here, when we do this stuff, let me think. So the issue is now, okay, we recorded where it should, like where the patches should occur. But we don't actually, like I said, we don't have this global storage of all the labels right about now. And if we don't have that, we don't have anywhere to iterate over all of them. We could try to cheat right now and say that do this patch right when we encode if we already know the target. That could actually work out, I guess. So here, maybe it would be better if this is U8 star, just for the arithmetic to be nicer. That's fine. When we do function start though, here our operand is gonna be now label 32, and this label 32, yeah, it we need to allocate it. So temp allocate label. That's good. And we actually do know where it's pointing to here. So we can say function value operand label target is buffer, builder dot code. Okay. Now I'm ready to try it out again, but I will not try run test. Rather, I will go directly into the assembly and see what is going on. This. Okay. Access violating writing to location 0. So something did not get initialized correctly, and that's because I put the label in the wrong thing. It's no longer here. It's no longer here. Instead, it is here, where we say, I guess this will happen now inside of here, where label 32, no, say label star, label is whatever, label locations, or better, star label is label That's good. And now we can also actually put the target right away here as well. Say target is builder code. That's good. And then this is temp allocate of label. Okay, let's try that again. Assert operand type immediate 64. Oh, that's a bit problematic. Because right now, yeah, previously it was a location, now it's going to be something different. Helper value as function. Okay, and we assert that it is label 32, and then we say we also assert that value operands label 32 target, and this is what we return, I guess. And now this can be function type opaque. Differs in level of interaction from U8 star. You don't say. Okay, let's see if this fares better. Okay, at least we progressed again to the point where there is something in assembly. Although, yeah, it still can't really, it's still gonna be CCC stuff, right? Yeah, so we still have this issue because we did not actually patch, which is what I was going to do. Okay, so we do have a label. Now, what do we say? So we can do patching right away. Say if operand label 32 target else. So basically, instead of having uniform loop, we say, okay, if we already know where we should jump, well, let's just freaking calculate where we need to jump and do that. So we say that what is it? Base is U8 star from is going to be buffer memory plus buffer occupied plus size of S32. This is like the end of the current instruction, and we just write out the difference between that and the target. So we say target, or actually, yeah, target minus from, or from minus target. Yeah, from minus target. If the target is before us, then, and we can actually assert. So we can say S32 diff is this, and assert diff less than 0. Target is this stuff, and diff goes into here. Yeah, I'm aware that it can overflow, but it shouldn't. Good. Try once again. assert diff less than 0 fails. What is diff? It is 47. Yeah, it should actually be the other way around. I always have problems with this kind of calculations for some reason. Do not know why. Okay. Can we get to here? Let's see what is going on. So it's gonna jump to where? DBB0019. That does not seem like a good idea to jump there. There is nothing really there. So what am I doing wrong right now? There's also a bunch of moving here. Okay, this is fine. We call, we save the result, then we do a bunch of moving around, which is also fine, and then we return this kind of stuff. Okay, that's fine. But why is this so weird? BB00. So none of the stuff around us actually is code. And this is already very, very strange. Because it should be. Right? We are in this test here. And these two functions should be okay. They should be actual code. So why aren't they? Call function value. Okay, this is what the call looks like now. Yeah, this is fine. Like this is what we changed now. It's okay if it is like this. But the question is, okay, let me check something. We have this size of S32. Where are you? Okay, I guess, yeah, this is what I want to do. I want to extend this test a bit. And I want to say size of S32. Or actually size of S64. Let's just take one of them, it doesn't matter. And it's gonna be 8. And the size is, the type is correct here. So is not a function. Size of S64, let's call this value. Okay. And now I want to actually stop here and check if this function makes any sense at all. Because it's very strange that we don't see the code for other functions next to them. It's almost like we are not even writing it out, which is very, very strange. Okay. So Yeah, now I do see this code. Maybe it just doesn't disassemble what comes before it. Okay. Maybe it's actually all right. Let me say continue. Okay. It seems that it might be actually okay. And it looks like it is. Okay, so it just was the disassembler doing some weird things. Cool. So this part works. This video did not go as smoothly as I would hope, but that's fine. It happens sometimes. Hopefully the next one will be better, and I'll see you when that happens. See you then.